So the world needs energy. We need energy for our standard of living and also for quality of life. Nuclear energy is a very excellent option for providing the energy that we need. There are two fuels in the world that we can use for providing nuclear energy. One is uranium, which is what we use now. So we bombard uranium with neutrons, and it causes the isotope U-235 to split, releasing energy. Also, we can bombard uranium-238 with neutrons to transform it into plutonium, which is another fissile fuel. So both plutonium and U-235 undergo fission to release energy for nuclear energy. So that's good. Also, what's really good news for us is that in the world we have huge reserves of uranium. There's over 30 million tons of uranium and an additional 4.6 billion tons of uranium that can be found in seawater. So we have lots of uranium. However, there's another element found on the Earth, thorium. Thorium is a slightly lighter element. It's got a Z number of 90. It's another fuel that we can harness to provide energy. So naturally occurring thorium is what's called fertile. It doesn't undergo fission. But if we bombard thorium with neutrons, it will transmute into another isotope of uranium, uranium-233. And uranium-233, which is very similar to uranium-235, is fissile. And when we bombard that with neutrons, we can also create fission energy. Now, what's really exciting with thorium is that thorium is 3 to 5 times as abundant as uranium on the planet. So this represents a very huge energy resource to provide the clean energy that the world needs. Now, also the good news is that thorium, as an alternative nuclear fuel, can be used in any reactor technology. That includes the reactors that we use in the present day, Generation 3 technology, such as light water reactors, and also pressure tube heavy water reactors. And in the future, we could also use thorium-based fuels in small modular reactors, Generation 4 reactors, and other technologies. So thorium can be used in any reactor technology. Here in Canada, the pressure tube heavy water reactor that was developed in Canada are very well suited for using thorium-based fuels. They're excellent for using thorium. In the near term, what we can do is mix slightly enriched uranium with thorium and use that in a conventional CANDU type reactor. Another option is to mix thorium with plutonium that's found in spent light water reactor fuel. So we have many options for using thorium-based fuels. And in the short term, what we should do, what we'd like to do, is to build various types of prototypes to demonstrate that technology. In the long-term future, what we want to see happen is using what's called the uranium-233 thorium cycle, where we actually develop reactors, thermal spectrum reactors, such as using CANDU technology, to have a reactor that actually produces more fissile fuel than it consumes. And it becomes fully self-sustaining, and we involve full recycling of fuel, which is really good news. So with a future generation reactor operating with uranium and thorium, the input will be thorium as the new primary nuclear fuel, and the output will be clean energy. So that's good. So the good news is that for long-term energy security, we've got plenty of uranium, but we also have 3 to 5 times as much thorium. So this is very good. Thorium is actually a gift to humanity to provide us the clean energy we need. Thorium is good, and we should use it. Canada has the technology with the pressure tube heavy water reactor. We know how to use it, and we can make it better. Here at Canadian Nuclear Laboratories, we have the people, the staff, facilities to make thorium-based fuels work and to make them work better. And this represents a unique opportunity for Canada and for Canadian Nuclear Laboratories.